making myself laugh. Okay, part one, transversals. So we notice this pattern, right? Where in a triangle, we have this angle on the outside of the triangle that adds up to the two angles on the inside. And there is actually a reason for that. But before we can get into the reason for that, we have to talk about something called transversals and parallel lines. Okay? So in geometry, anytime we have two parallel lines and another line going through them, we have a terminology for all of these different angles. Okay? So these two lines are parallel. This is considered a transversal because it cuts through them. Okay. Transversal. And we can show that these are parallel with this little symbol, or no, I think it's actually more common to see it twice for some reason. But either one or two arrows on both lines, showing that those are parallel to each other. The first thing that we can show about these is there's something called the corresponding angle postulate. Because this is a postulate, we're not going to try to prove it. But corresponding angles are angles that are in the same place. If we were to pick up these four angles and put them over the top of those four angles. And it turns out that corresponding angles are congruent. Or if we wanted to show this mathematically, we would say angle 1 is congruent to angle 5, because those are corresponding. What else could we show? What are some other corresponding angles?
Angle 1 and angle 7.
Okay, hold on. We're not there yet.
Or 3 and 7.
3 and 7 are corresponding angles, so those would be congruent. What else are corresponding angles? 4 and 8 are congruent because they're corresponding. There's one more set.
2 and 6.
2 and 6 are corresponding, so they're congruent. Now, Mira said something really interesting. She said 1 and 7 are congruent. Are those corresponding angles?
Yes.
No. 1 is corresponding to 5. Each angle only has one corresponding angle. Okay? But it actually is true that 1 is congruent to 7. And we can prove that. So this is going to be called alternate exterior angle theorem.
Because if you move them, they would be vertical.
Yeah, and this proof is one of the shortest proofs you'll ever do. Okay? So the alternate external angle theorem says that, we're going to give these names. What did I call them? If K is parallel to L, then 1, angle 1 is congruent to angle 7, and angle 4 is congruent with angle 6. And the reason we call these alternate exterior, I will tell you, one of the most difficult things about this is getting all these names straight. So understanding, like corresponding, okay, corresponding, same place, right? 1 corresponds to 5, 2 corresponds to 6, 4 corresponds to 8, 3 corresponds to 7. Corresponding. Alternate exterior, they're on alternate sides of the transversal, and they're exterior to the other parallel line, right? So 1 is alternate and exterior to 7. You guys see why we would call it that? If it's on the inside, we would call them interior, alternate interior angles.
Wait, which one?
So the 2 sets of alternate exterior angles here are 1 and 7 and 4 and 6. Okay? And this says if these 2 lines are parallel, then angle 1 is congruent to angle 7 and angle 4 is congruent to angle 6. The proof is really simple. The proof goes like this. Angle 1 is congruent to angle 5. How do I know that? What's my justification?
The corresponding angle postulate.
Yeah. So we're going to do a 2-column proof. Corresponding angle postulate. Step 2. Angle 5 is congruent to angle 7. How do I know that?
Vertical pair.
Yeah, this is called the vertical angle. It is a theorem. Remember we proved it?
And that's the, what's it called, rule where A equals B and B equals C, so A must equal C.
Yeah, so then if angle 1 is congruent to angle 5, congruency is just like equality. Okay? The properties of congruency are the same pretty much as the properties of equality.
What's that rule called?
So I'll tell you. So we can say that angle 1 is congruent to angle 7 because they both equal angle 5. Now we could call that, like when you were learning systems of equations, you called this substitution, which is fine. You can call that the substitution property of equality if you want to. There's another name for it, which is the transitive property.
Yeah, that's the one I know.
Yeah. And that's, some of these things are good to start picking up. So I'm going to use that term here. The transitive property, that just says that if one thing is equal to another thing, and then that other thing is equal to a third thing, the first thing equals the third thing. So transitive is like we take 2 equations that both are equal to the same thing, and we combine them into one equation. It's usually said if A equals B and B equals C, then A equals C. That's transitive. You could also justify this with the substitution property though. That's fine. And the thing about proofs is there's never only one way to do them. Right? There's usually many, many, many correct ways. Now the shorter the proof is, the fewer correct ways there are to do it. Well, sort of. You could always make it longer. But the fewer steps you can kind of move around. It's getting a little cramped. I'm going to move this diagram over. Okay. Okay, so this is called alternate exterior angles. Who can tell me what are the alternate exterior angles in that diagram? there's two sets of alternate exterior angles. What are they?
1 and 7 and 4 and 6.
1 and 7, 4 and 6. Okay. Now while we're showing that things are true about this diagram, let's talk about those alternate interior angles. So with alternate interior angles, we have another theorem, which says, anyone want to guess? So remember, alternate means opposite sides of the transversal. Interior now means on the same side, like facing each other on those parallel lines.
2 and 8 and 3
So
and 5.
2 and 8 or 3 and 5. What do you think is going to be true about those? 2.
If 2 equals 4 and 4 equals 8 and 2 equals 8.
Ah. So you think that 2 will be, and I'm going to make a really important distinction here, congruent to angle 8.
Oh, I got it. If 7 equals 5, and if 7 equals 1 and 1 equals 3, that, no, wait, yeah, 7 equals 5, but 7 also equals 1 equals that.
Okay.
But
And
you made it more confusing.
angle 3 is congruent to angle 5. So those are our sets of alternate interior angles. Okay. So yeah, let's follow your proof for this. What would be the first statement you would make?
7 equals
Okay, again,
5. Congruent.
say congruent.
7 squiggly equals 5.
Okay, so angle 7 is congruent to angle 5. Why?
Because they are the vertical
Vertical
angle.
angle 0. Okay. What would be a good next step? So if we know these are cool. We're trying to show probably this one, right? Mira is what you were going for?
Yeah.
We're trying to show that 3 is equal to 5? Yeah.
And 7 equals 1 because of the alternate exterior angle.
7 is congruent to 1.
Okay.
Is what the alternate exterior angle theorem shows. So 1 is 7.
And 1 is congruent to angle 3.
Okay.
So, yeah.
So angle 1 is congruent to angle 3. Why? Okay.
Therefore, angle 3 has to be congruent to angle 5.
Yeah, so actually we have 2 steps left, right? We have to show first angle 7 is congruent to angle 3. Right? Because there's
Because
nothing
angle 7
there's
equals
nothing
angle 1.
here. We know angle 3 equals angle 1 and angle
That's just the transitive
5
property.
equals angle 7.
The transitive property 7.
Right. So 7 is 3 through the transitive, or we could say 5 is 1 through the transitive. Yeah, or we could have used the corresponding angle theorem here, right? We could have just said angle 3 for the corresponding angle postulate. Angle 3 is congruent to angle 7 because of the
which
corresponding.
other
So
types of
instead of these steps, we could have done angle 7 is congruent to angle 3, and the justification for that is the corresponding. This is what I meant when I said there's never only one way to do a proof. Right? So this way works fine. We do have to show that angle 7 is congruent to angle 3 through the transitive property. And angle 5 is congruent to angle 3, also through the transitive. One of the keys with proofs, this one Mira got here, she said, oh, so angle 5 is congruent to angle 3, which a lot of you can probably see because 3 equals 1, 1 equals 7, and 5 also equals 7. So they have to be equal, but we haven't actually proved that yet. We have to use the transitive property to show that 7 equals 3, right here, before we can then use the transitive property again to show that 3 equals 5. Let me see how I printed out a proof of this. Yeah, that proof that I printed out is way longer. It's kind of interesting. I like your way better. All right. Questions on this? So, I think that's actually, it's probably a good place to stop today. We just have to go over 2 more terms though. Can I erase this?
Yep.
So, first term that we need to go over is okay, so we talked about corresponding, which means what?
That they are in the same place.
Yeah, this sort of the same place relative to the transversal. Right? So like angle 1 in this diagram is to the top left of the transversal. You could sort of say. Does that make sense? Mm-hmm. And angle 5 is also on the top left. Then we talked about alternate exterior, which means exterior means
I said they were outside.
not facing each other. Yeah, like outside.
Mine said on alternate sides of transversal and exterior of parallel lines.
Outside and opposite.
Outside and opposite.
Uh-huh. And then alternate means opposite sides of the transversal. And so then alternate interior interior. So alternate again means the same thing. Opposite sides of the transversal. The interior now means that they are on,
Inside and opposite.
yeah, the inside. I think that, I'm not totally sure about this, but I think that technically the definition of exterior and interior depends on the parallel line. So 2 interior angles would both be on this inside of the parallel line, right?
Yeah, inside.
Something like that. So they're actually on opposite sides of their parallel lines. Like this one's on the left of the parallel line, and this one's on the right of the parabola. And then the last terms both depend on the word consecutive. And these ones actually, there's a few, I've seen different terminology for this, but like a consecutive interior angle, this means that they're on the same side of the transversal. And the reason I think that there's different terms for this is these are just not used as much. Alternate exterior and alternate interior is much more common. So consecutive interior angles would be 2 and 5, or 3 and 8. Anyone want to guess what the relationship between those is?
Together
They're-
they equal
they're-
180.
Yeah, together they would add up to 180. So they're supplementary. Consecutive interior angles. And then I guess sometimes you'll see like consecutive exterior, which would be like 1 and 6, or 4 and 7.
Which would also add to 180.
Right, which would also add to 180. And we could prove those facts as well, if we want to. I don't think that we will.
Cool, if you moved
We
them,
definitely
then
won't
they
today.
would, and they were back to back, it would make one. Okay.
A lot of these proofs are using vertical angles, corresponding angles, and then transitive property. In this case, actually, we'd have to use linear pair and then transitive. You can probably imagine that proof, right? We know that 1 plus 2 equals 180. And then we know that 5 plus 6 equals 180. And then we could say we know 1 is equal to 5.
We can equal that 6.
Okay. All right. So mostly the homework tonight is going to be applying these things. I'm not going to give you homework tonight over the actual proof of them, but applying the terminology and then applying what we learned. So 1 and 7 are equal, right? 2 and 8 are equal. Trying to see those relationships between alternate exterior and alternate interior, as well as some vertical angles and things like that.
What about tomorrow on the
Corresponding.
quiz? Are we going to have to prove things?
No. Tomorrow your quiz will be very similar to your homework. Not the same problems, but